Hello, everybody. So we are getting into chapter 7 today, looking at 7.1 interior and exterior angles. All right, go ahead and get this title, get the definition for polygon interior angles theorem, get this whole thing, and then we'll look into it. Okay, so yeah, we're starting out with what's called the polygon interior angles theorem. All right, and here's what it says. It says the sum of the measures of the interior angles of a convex polygon with n sides. We can find that using this little formula, this theorem. Okay, so basically, here's the idea. If we're looking for, again, the sum of the measures of the interior angles, so for example, over here, what do these six angles, when added together, what does the sum of those angles equal? We can figure that out by using this formula. All right. So let's go ahead and do that. If you guys notice, when we say n, we're talking about the number of sides that a polygon has. Okay. Or you can also think of it as the number of angles that a polygon has. Okay. But either way, let's think of it as the sides. I think that's the easiest way. Okay. And if you guys take a look at this, this polygon here has six sides. All right. So n equals 6 in this case. And let's go ahead and plug it into our little formula here. Okay, so it has six sides. We're going to plug in 6 for n, and then we always have this minus 2 as part of the formula, and then times 180 degrees. All right, so again, calculator, you'll want one. So from here, we can do some of this in our head. 6 minus 2 is 4, so we're getting 4 times 180. All right, and then from here, multiplying those numbers together, you might be able to do this in your head. Looks like we're getting 720 degrees. Okay, so again, here's the idea. What we just figured out was what the six angles of this triangle, or sorry, triangle, of this polygon add up to. Okay, they all add up to 720 degrees. Here's something I want you to think about. When we were dealing with triangles in the last chapter we were looking at, we knew that the three angles of a triangle always added up to 180 degrees, right? That was one of those fundamental things we knew. So say we use that same idea with this formula. Okay, well, there's three sides to this polygon, right? So we would plug in 3 for n. So we would get 3 minus 2 times 180. And yeah, 3 minus 2 is 1. 1 times 180. The sum of the interior angles of a triangle would be 180 degrees. Okay, so my point is that this theorem, it still works with triangles, though we've memorized that triangles angles add up to 180. You probably have not memorized that a object with six angles adds up to 720 degrees. Okay, so that is the purpose of this little formula right there. One thing you might want to do in your notes is put a nice box around this thing. Normally when we have formulas that are kind of important or something that we're going to be using a lot, always recommend putting a box around them just so when you go to look back in your notes, it'll catch your eye real quick and you'll be like, okay, there it is. Okay, so yeah, with this, let's try out some examples. Before we do though, classifying polygons, let's go over the names of the different polygons that exist. You guys know that polygons, as they increase in size, their names change. All right, so let's go through this and just kind of remind you. These are probably some things you've heard and some other ththings you haven't. Okay, so go ahead, take a second here and write out this slide here. We're going to start with three sides and we're going to make our way all the way down to 12 or n sides, and I'll show you what that means. Okay, so this here, go ahead and get that, and then we'll go all the way down to 12. Okay, so we're looking for the name of a polygon with this number of sides. All right, so starting out with a polygon with three sides, we all know that. That's called a triangle, right? Okay, so go ahead and add that to your list. Something you probably won't forget, but it's good in the context of everything else. Okay, the next one, when we have a polygon with four sides, what is that called? Okay, you might think it's called, a square, maybe a rectangle. No, those are types of four-sided polygons, but the generic name for any four-sided polygon is a quadrilateral. So, quadrilateral. Okay, next one, a polygon with 5 sides. All right, you guys have probably seen the building, called the Pentagon. It's called that because it has 5 sides, and yeah, that's exactly what it's called here. So sided polygon, Pentagon. Okay, a 6-sided polygon. What is that called? Hexagon. Okay. A 7-sided polygon. This one's a little bit less common. This is called a heptagon. Okay. An 8-sided polygon. This is maybe the most common one, which is called an octagon. Okay. A 9-sided polygon. This is one we don't see very often. This is called a nonagon. All right, a 10-sided polygon. What is that called? A decagon, kind of like a decade. Decagon. Okay, and we're skipping over an 11-sided polygon, though if you were curious what that was called, that's called a hendecagon, but that's not something you'll see very often. But moving on to a 12-sided polygon, this is called a dodecagon. Okay, and those are kind of the more common ones that you'll see as we go through it. One other thing you'll see is a polygon with n sides. All right, it's kind of weird, but n just represents any amount of sides. So what we're going to do is in this class, if we have a polygon that has more than 12 sides, we're going to just call it a 13gon, a 14gon, a 15gon. All right, so just to use n as my whatever my number happens to be, we'll call it an n-gon. Okay, and if you want to just kind of maybe show yourself, for example, 13gon, or you can say like 19gon, if it has 19 sides, we're going to call it a 19gon, though it probably does have a name. They just kind of get weirder and weirder. Okay, so there's a nice little review on that. All right, so with that, I'm going to have you guys find the sum of the measure of the interior angles of this convex octagon. Okay, so that's the big thing. It's an octagon. So, even if you didn't have a picture, you could probably find what the sum of these interior angles added up to, because you know how many side lengths an octagon has. Okay, again, the little formula you're going to be using is the n minus 2 times 180. Okay, so go ahead and plug in the number of side lengths in for n, and then see what these interior angles add up to. Okay, so octagon, again, whether we had a picture or not, we can count them up. This thing has 8 sides. Okay, so if we want to just kind of point out to ourselves on this, n equals 8. So over here, there's our work. So I'm going to get 8 minus 2 times 180. Okay, 8 minus 2 is 6, and 6 times 180 gives me 1080 degrees. Or 1000. I guess that works, yeah. So 1080. Okay, so yeah, that's what that formula is for. It's a good one because this is not something I expect you to memorize when we get to these, polygons with all of these different sides. What do these angles add up to? It's a really simple formula. Plug it in and you can figure it out. Okay, so now with that, we're going to use it to actually find missing angles and solve for x and all that fun stuff. Take a second and copy this example down. We'll try to. Okay, so we want to find x here. Okay, here's, I guess, the idea. First of all, x is just this angle. Okay, so what we need to figure out is what do the 4 angles of a quadrilateral add up to? What is that number? Okay, to figure that out, we can use our little formula. So let's go ahead and write out the formula one more time. So n minus 2 times 180. Okay, where n is the number of sides. This thing has 4 sides. It's a quadrilateral. So we're going to plug in 4 for n. If you want to show yourself, just, it's not a bad idea in your notes, just remind yourself, oh, n equals 4. Okay, so 4 minus 2 times 180. Okay, it looks like we're getting 2 times 180, which is 360 degrees. Okay, that's not the answer. That's not what this problem is asking for. It's asking us to find x. but now we know that all 4 of these angles when added together equals 360. So now we can make an equation out of this. All right, so that's exactly what I'm going to do. I'm going to add all 4 angles together, set it equal to 360, and solve. All right, so let's go ahead and do it. I'm going to start with a variable x. So this angle plus this angle plus this angle plus this angle. Doesn't matter what order you add these together, by the way. Those 4 angles we just figured out add up to 360 degrees. Okay, so from here, we're just kind of simplifying a little bit. Let's go ahead and add these 108 plus 121 plus 59. We're getting 288. So I'm getting x plus 288 equals 360. And then from here, now I can subtract 288 to solve for x. And let's see, 360 minus 288 is going to give me 72. Okay, and there it is. That's what x equals. Okay, this math is not really anything new. We've done this before. We did this with triangles, right? We added all 3 angles. We set it equal to 180 because that's what the 3 angles of a triangle added to. The only new thing on this was we had to figure out, oh, what do the 4 angles of a quadrilateral add up to? This was the new step. The rest of this is just stuff we've done before. Okay. All right, so I'm going to have you guys try out one of these on your own. All right, again, the first thing you're going to want to do on this problem is figure out what do the 5 angles of this pentagon add up to. All right, to figure that out, plug them into our new little formula here. Okay, once you figure out that number, what they add up to, and by the way, this is times, yeah. Once you figure out that number, then you can make your equation. You can add all 5 angles together, set it equal to that number, and solve. Give it a try. Okay, so first things first, we counted it up. This thing has 5 sides. Okay, so n equals 5. I like to just maybe make a little reminder in my notes just so I can refer back to it. Okay, but it looks like, all right, so I'm getting 5 minus 2 times 180. Okay, 5 minus 2 is 3, and 3 times 180, I don't want to mess up, so I'm putting in my calculator, is 540 degrees. Okay, so now I know what these 5 angles add up to. Now I can make my equation. All right, so I'm just going to kind of put it off to the side here. I'm going to start with 2x. I always like to start with the variable when I write my equations. So I'm just going to add them all up. 2x plus 96 plus 93 plus 156 plus 85. I'm kind of running out of room here. Okay, equals 540 degrees. So sorry, kind of ran out of room there. Okay, so now just like the other one, I'm going to simplify a little bit. Remember, this 2x, I can't add it with any of these other terms. They're not like terms. It's going to just stay, 2x. But I can go ahead and add these numbers on the left side of the equation. So let's see what happens. 96 plus 93 plus 156 plus 85 equals 430. Okay, and that equals 540. All right, from here, now we can solve. You guys know we deal with addition or subtraction first, so I'm going to subtract 430 from both sides. Okay, looks like I'm going to get a 2x equals 110. Okay, and then last thing, getting rid of 2 by dividing. All right, half of 110 is 55. And that's what we asked for, x, right? Just always double check, is that the question? Did they ask just to find x? Yeah, because potentially they'd want us to then plug this back in and find the measure of this angle, which, by the way, if we did 2 times 55, we get 110 degrees as this angle, if that was the question. Okay, cool. So that's that type of problem. We have one other type of problem to look at this lesson. I guess first thing, just go ahead and copy this example, and then we'll do this one together. Okay, so this is looking at this type of work from sort of the opposite direction. This is saying a polygon has an interior angle sum of 1,620 degrees. So it's telling us what the sum of the interior angles is, and it's asking how many sides must the polygon have? If all of the angles add up to this number, how many sides does that polygon have? That's the question. Okay, the good thing is we can still use our little formula on this. All right, so the number of sides, if you guys remember, that's n. Okay, that's what we're wondering. What is n? How many how many sides does this polygon has? So when we go to use our little formula, here's what we know. We know that this formula, the n minus 2 times 180, it gives us the sum of the interior angles, which they are telling us is 1,620. So we can set that equal to it. We can say, oh, that's going to equal 1,620. Okay, so now we have an equation, and again, we're trying to figure out n. We can solve for it. Okay, here's a couple little things here. The parentheses here. Before we can get inside of the parentheses and get rid of this minus 2, we need to get rid of everything on the outside of the parentheses. Okay, so it's a little different when it comes to solving this 180 that's being multiplied. Since it's on the outside of the parentheses, we need to get rid of that first. So we're going to get rid of it by dividing like we normally would. Okay, both sides. Okay, so now the 180s are gone. Now I have this n minus 2. By the way, since there's nothing on the outside of it anymore, I don't need the parentheses anymore. So n minus 2, and my calculator, 1620 divided by 180, looks like I'm getting 9. Okay, and then last thing, solving for n, I know I need to get rid of this minus 2 by adding 2, and it looks like that n is going to equal 11. Okay, so how many sides does the polygon have if its interior angles add to 1620 degrees? 11 sides. Okay, and they didn't ask us for the technical name for 11. Actually, that's not one of the ones that we listed, but that was a hendecagon. If you guys were curious, that's what it's called, hendecagon. Okay, but they didn't ask that. Alrighty, so I'm going to have you guys try one a lot like this. Again, they're saying a polygon has the interior angle sum of 900 degrees. Okay, if those interior angles add up to 900, how many side lengths must the polygon have? Go ahead and write out your equation just like we did on the last one and solve for n. Okay, so here's what I know. Our interior angle sum formula, n minus 2 times 180, we know that that gives us the sum of the interior angles, which they are telling us is 900. Okay, that's the hard part. If you can write that out, the rest of these steps are all the same, right? We're going to divide by a 180, and then we'll add 2 to both sides. Okay, so they're gone. I have the n minus 2 on the left. On the right, 900 divided by 180 gives me 5. Okay, adding 2 to both sides, and it looks like the number of sides that this polygon has is 7. Okay, so a 7-sided polygon, those 7 interior angles, when added together, add up to 900 degrees. Okay, not something you have to memorize, but it's just kind of a good thing to wrap your brain around. Okay, we have one last part to this lesson, and it's looking at what's called the exterior angle theorem. Okay, the other one was the interior. Now we're looking at the exterior angle theorem. Go ahead and copy this out. This one's an easy one. Okay, so here's what it's saying. The measure of angle 1, which right here, this is the exterior angle, if you want to highlight it. Okay, notice it's called an exterior angle because it's on the outside of our polygon. This is our triangle, our polygon here, and this is the exterior angle. Okay, so how can we find the measure of this exterior angle? Well, here's all we have to do. It equals the measure of this angle plus the measure of this angle. Okay, so these two angles, when added together, equals our exterior angle. It's that simple. Okay, so quick example. If this was a 10-degree angle and this was a 30-degree angle, this would be a 40-degree angle. Okay, adding them together. It's really that simple. Okay, so let's try it out. Okay, so real quick, I'm gonna have you guys just take a look at this one. You don't need to copy it, but just take a look at this. If these angles A and B are 70 and 30 degrees, what is the exterior angle going to be? Find x. Okay, we could write out our formula. Okay, I mean, but really, these numbers are so easy. We can just do it in our head. We know that we just add these together, and 70 plus 30 gives me 100 degrees, and there it is. That's my exterior angle. Okay, so again, it's really that simple. Add together these two angles, and it gives you this exterior angle. All right, real quick, I want to just show you why this works. Okay, if this adds up to 100, if you guys remember a triangle, the 3 angles of a triangle add up to 180, right? Well, think about it this way. if these add up to 100, that means this angle here would have to be 80 degrees, right? For them to add to 180. Well, if these two angles make a flat line, they should add up to 180. If that's 80, this is 100. Okay, so even if you didn't know this little theorem we just learned, you guys still have the ability to find this exterior angle using the other skills we've learned in the past. So really, this thing, it's just a shortcut. Okay. Okay, so with that, I'm going to have you guys try out one of these where we're actually going to write an equation. Okay, these are harder, weirder values for our angles, so you actually need to use this equation here when making this problem. You're going to say the exterior angle equals the two interior angles added together. All right, so go ahead and do that with this problem here. Give it a try. Okay, so again, my exterior angle equals the two interior angles added together. So I'm going to start with that. My exterior angle is at 2x minus 5. By the way, when you're writing your equations, you don't need these parentheses if there's nothing on the outside of them. You don't need the degree symbol. So the exterior angle, I know, equals the two interior angles, A and B, added together. So x plus 70, or you can do 70 plus x. It doesn't matter. Okay, so there's my equation. Now I can find x, right? I notice variables on both sides. So remember, we can bring them to the left or we can bring them to the right. I'm going to take this x and subtract it over to the left. Okay, so 2x minus x gives me 1x, or just x, bringing down the minus 5. X's are gone on the right. We have 70. Okay, and then last thing, adding 5 to both sides. I'm just going to do it in my head. Looks like x is going to equal 75. And there it is. Okay, so yeah, that's a nice little theorem there, but really the big thing to take away from this lesson today was the interior angle theorem. Okay, this formula right here at the very front, this guy. Okay, that's one that you'll use, ever so often throughout the year. Okay, all right, guys, I'll see you in class. Bye.